in the reporting level.
Yeah.
Okay, so that is how we make use of the master data in the reporting level. Fine. Now here the problem is what they are doing. They are supplying in this way itself. The master data is supplied along with the transaction data. Okay, or I mean to say, this is how it would be if you go with a star schema. Okay, so what is the problem is your attributes as well as the main object. The entire master data is stored within the dimension table. Okay, so you have so many master data, right? Millions of master data. So that much amount of data is stored in the dimension table, and this dimension table, as I told, the same cost center field can be available in another cube. So this cost center dimension I cannot use in another cube. In another cube, I will have another cost center dimension specific to that. So again, in that cube, in that cost center dimension, this much millions of master data again will be stored in the dimension table. So is it not the bad practice? The master data is being stored redundantly across dimensions tables.
Yeah, it repeats it. Yeah.
Yeah. So this is the main drawback if you try to go with the star schema.
Is it repeating, or is it would there be a new set of data
it all depends. Like
that keeps storing in different cubes?
It's corresponding to the transactions. Like for whatever, like in this case, these two cost centers, the transaction happened, that master data is stored. In another case, some other cost center transaction happens, that entire master data with attributes will be stored.
Oh, okay.
Okay, so corresponding to the transaction, whatever master data is there, it is stored in the dimension tables. So this is the main drawback which we are seeing in the star schema. The master data is maintained across the dimensions. Okay, in classic star schema, the master data is stored in dimension tables, so it is not reusable. If the characteristic is included across multiple cubes, we have the dimension across all the cubes. And
in the classic way, this cannot be overwritten into only one dimension, or that needs some kind of modification.
No, it's a like this is the only possibility.
Okay.
So just go through this sentence. This highlighted one. So just now, as we discussed, that is what I have written down. So this is the main drawback. So in order to overcome this drawback, we have to do a couple of things. Okay, so let us see what we can do. Ideal thing would be, first of all, the data supply should be in a proper way. Master data should be supplied separately, transaction data should be supplied separately. That is one way to start streamlining this one. Okay, so in that case, as we discussed, this would be the master data, and this would be the transaction for the cost element. This would be the master data. The cost element you will load into cost element and one SR indicator info object. Cost center you will load into cost center, controlling area and person responsible info objects. Fine. Likewise, the transaction data they would supply in this way. Okay, just imagine if this is the where they have supplied. Our goal now is to modify the star schema so that we overcome this disadvantage. The master data should be reusable. In earlier classic star schema, the master data is not reusable. It is stored across all the dimensions. Okay, so now what we are doing, the data is supplied separately. Again, what does your fact table contain in this case? If this is how the data is supplied.
Fact table is amount and quantity, right?
Okay, and dimension IDs. That concept would still remain, right?
Yeah, there are two dimension IDs, right?
Okay.
The cost center and then there is cost element.
Okay, and
the time.
Correct. So you have three dimensions: cost center, cost element, and time. So the dimension IDs and key figures will be stored in the fact table, and these are, you have three dimensions. Okay. Now in each dimension, like for example, cost center dimension, what you will be having? In earlier case, if you go back to earlier scenario, what we had the dimension ID, then main object attributes. In this case, what you would be having?
The cost center and attributes, right?
And dimension ID.
Correct. No attributes, because we are trying to avoid that.
Oh, okay.
In this case, we have been supplied data separately, right? We have the attributes are not coming as a part of transaction data.
Yeah.
Okay. So from BW perspective, the data is supplied properly. So as you said, it contains the cost center dimension ID and cost center. Likewise, your cost element dimension, what does it contain?
The element here, which is
Element and the cost element dimension ID, right?
yeah.
Okay. Likewise, time. Time will contain time dimension ID and fiscal period, fiscal year. Okay. So same again, your corresponding dimension IDs are linked to your fact table. Fine. So is it better compared to your earlier scenario, wherein we were storing entire master data?
Yeah. Yeah.
Yes, yes.
Okay. But are you still storing any master data in the dimension table?
Master data should be separate, right? Or
Yeah, but going by this design, are you still storing master data in dimension table?
No.
no.
Yes, right? Whatever values these are the master data only.
Some of that. Right.
It's a cost
So,
center. The corresponding
the only betterment what I can say is you are not storing the attributes, but the main object you are storing.
yeah.
The master data for main object.
Hmm.
So it's slight betterment, but still the same issue remains.
So you're saying is you remove the attribute of the main data. Oh, main. Okay.
Correct. Yeah, but still this is not a perfect design, right? Because the problem is master data is not reusable. It is being stored across all the dimensions. In this cube, in this cost center dimension you have it. In another cube, another cost center dimension, again you have to store. You have to keep on storing in each cubes. So this is the problem. So to avoid this, what they are doing is they are using a concept of SID. Okay, so let us see what they are doing. Okay, so So like getting aside from this cost center example, I'll show another example similar to this. So okay, so this is the example. Here what you are finding, I have just written down the data. So this is how the data is. You are supplied customer master data, material, material group, material name. You have material master data. Likewise, you have supplied customer master data, customer, city, region. So likewise, a transaction data you have been supplied, customer, material, month, year, sales, quantity. So can you tell me what would be my first step given this data as a part of cube design? What should I first do?
Create a dimensional table for master.
Correct. You have to identify the different dimensions, right?
Right.
So how many dimensions would be there in this case? Just look into this data.
Customer, material, month, year, quantity.
3 dimensions.
3, 1,
Yeah.
2.
Correct.
One fact, right?
Yeah.
One customer, one
So
material.
you have so customer one dimension, material one dimension, time one dimension, right?
Come on, yeah.
And likewise, what does your fact table contain in this case?
Sale and quantity.
Sales and quantity.
And dimension IDs.
Or dimension ID, yes.
Okay. So your customer dimension just now previous betterment, what did we see in custom, like based on the previous betterment, in the customer dimension what you will be having?
Dimension ID and the customer.
And customer, right?
Yeah.
Yeah. So now just going one step further to eliminate that issue also, what they are doing is they are having an SID over here, SID of customer. Okay. If you recollect, SID table, is it giving a link between SID and the value, characteristic value?
Yeah.
Correct, yeah.
It has to be unique, yeah.
Correct. So now what is happening is, for a particular scenario, I link it from the fact table. I first go to dimension table. So what do? I take the dimension ID, okay, and go to the customer dimension table. Okay, so it's just like if you think about Olympic races, there will be 4 people will be running. First round one person runs, then he gives it to the other person, then another person, like that. Here first what it does is, for example, if you want to find customer and quantity in the report, customer related quantity, so corresponding to the quantity, it takes the customer dimension IDs. Using those dimension IDs, it goes to the dimension table. Now in the dimension table, it will get corresponding SIDs. Yes, clear?
Right.
Okay. Now, but SID is a internal notification. It is not a value. Is in which table will I get the value for that customer? Is it in the SID table? To put it in a simple way,
Yeah.
provided SID, provided I have SID, can I get customer number from the SID table?
Yeah.
Yes.
So if you just go through the design, it takes the dimension ID of customer, goes to the dimension table. Over there it gets SID. But SID is not a value as per my report. I want to see customer and sales, customer and quantity. I am getting SID of customer. That is not my output. But using this SID, I will go to SID table. Over there what I will get?
Customer ID.
Customer ID.
Customer ID. Corresponding customer ID I will get. So that is how it's the navigation is happening. Now just in case I want the attributes, the city and region, then I have to go one step further. Taking the customer ID, I go to the attribute tables, the P table, Q table, these will be the different attribute tables, master data tables. So taking customer ID, I go to master data table, I get the attributes.
So we're going
If I want-
sorry.
Yeah.
So we're going out of the cube then. So we are not anymore
Yeah, correct.
storing the data in the queue. We're referencing a table actually, right?
Correct. So in this case, like if you compare to the earlier betterment also, there is no master data within the dimension table.
Yeah.
In first case, we had master data and attributes. In second betterment, like second betterment was not proposed by SAP. Like just for our understanding, I gave you. So in second betterment, we had still the customer master data.
Yeah.
The attributes were not there, but master data was there. This is the final, the main betterment suggested by SAP. In this, only SIDs will be there in dimension table. So the master data is not at all there.
So how the clients give us the data? They give us a
No, we just load the data normally. This is a back-end linking happening.
it's a backend meeting.
Yeah. We don't create the dimension tables, fact tables also. It's just back-end links happen. Just for our understanding how it is happening.
Okay.
Okay. So now, if I am dealing with a sales scenario, I will find customer in all the cubes. So in this cube, the customer is accessing the master data, getting the data. In another cube, the design will be the same. Customer is accessing master data and getting data. So with this help of this design, can I say that the master data is reusable?
Yes.
Yeah.
Okay. So that's the betterment. So that's why what they are saying is, it is called as extended star schema. So the normal star schema concept, they have modified it to suit BW requirement. So it is called extended star schema or BW star schema, like that. Okay. Just in case, if I want the text, I have the customer ID, I want the text. How can I get it? In the text table,
Yeah.
by taking the customer ID, if I go to the text table, it will get the text. Likewise, if I go to the hierarchies, it gets the hierarchies. It's a simple thing. Okay, this is happening in the backend navigation, like when you run the report or getting any data, this is how the linkings are happening and data navigation is happening. Okay, so now let us just try it out for material. Okay, so can you just tell me how the data will process? Like for example, if I want to see a report, material versus quantity, which material topmost quantity I have sold, how it will proceed?
So material ID.
Material ID. The
Say the
Material dimension ID it takes for all the quantities, whatever records are there, corresponding to them, it takes the dimension IDs of materials, right?
Right.
Then where does it go?
SID material table or something?
SID, yeah.
Yeah.
Material dimension table it goes.
Material table.
It's still going to the material dimension table only, but what does it get in the material dimension table?
The corresponding SID.
Correct. For those dimension IDs, what are the SIDs of materials it will get? Okay. Now having got that, what it will do, where it will go further?
For the material.
For the material table.
For the material data.
Just think about it. I am having SID. I want to get the value. Which table?
The SID.
Is it the material table?
SID table.
SID table, yeah.
To be more accurate, material SID table I can say.
Okay.
Okay. So material is an info object, it's SID table. So over there corresponding to SIDs, what I will get?
The material.
Material ID.
Material.
And
Correct. The material number we can say, material number or material ID. So that is sufficient. If suppose after getting this information, material and quantity, user is further drilling down. He wants to add the attributes. Okay. So he is adding the attributes. So how does data further fetches like further how it is navigating backend?
We can add the material attributes.
Okay. Yeah, in the report level you add it, but how it is like using what it will fetch the attributes?
Yeah, it will get it through the SID. It links through the SID, right?
No, the SID link is already, no, SID link we use to
SID.
until we get the material value.
Material value. The material value will fetch the, okay.
Correct.
Will fetch the attribute and text.
Yeah.
Oh.
So is there any table where I'll have material value and attributes?
Oh, zero material?
There is an attribute table for material.
Yeah. And the
in
text
that
table.
I will have in the attribute table, what information do I take and go to the attribute table?
Material ID, right?
Correct. Corresponding to that, I will get all the attributes from there. Likewise, if I want to get the text, like in the report level, if I want to display the text.
Yeah, the material ID will fetch the material name.
Correct. So I go using the material ID, I go to the text table, and from there I can fetch the text, right? So the basic thing is, for an info object, what are the important tables? You should just brush it up. Let us see that. Zero material. It's not yet available in this system. They have freshly installed, right? So install that. Okay, just
Yes.
Are you okay? Okay. So this let- this material info object might not be available. Let us check some other info object. Zero comp code. Let us see. So what does SID table of company code contain?
Company code ID. Company.
SID and company code value.
Right, right.
Yeah, we can just say that SID table contains SID and characteristic value, right?
Right. Right.
Okay. So if you go by this flow, it first goes to dimension table. There it gets the corresponding SID. So using the SID, we can get the value. Okay. Now I have a characteristic value. Where do I need to go to further get it? Further get the attributes.
So we go to the whatever is the ID company code ID. Right?
Attribute table. Attribute table, right?
Attribute code.
Yeah.
Just make yourself clear about it. That's why I'm showing you in detail again these things. So the attribute table. So if I have if I have a value and need attributes, I get it in the attribute table.
Okay.
Okay. So that's what it is showing, corresponding value and all the attributes. Likewise, if I have a value and need the text, where I will get it?
The text table.
Correct. Likewise, if I have the value and need the hierarchy.
Yeah, hierarchy tab. Yeah.
Yeah, correct. There will be, if hierarchy is enabled, there will be hierarchy tables. So this is how the flow will be. So just custom yourself to this flow. So only two things. The earlier was a classic star schema. Now they have modified it to extended star schema. So what's the benefit you are feeling with the help of this star schema, extended star schema? What main benefit we are getting?
So we don't need to, restore that master data again in Cube, so it stays external.
Correct. So the master data is not stored within the dimension tables. You can see the difference. In classic star schema, the master data is there in the dimension tables, whereas in extended star schema or BW star schema, the dimension table do not contain master data.
Okay.
So in earlier case, the dimension means a dimension table only. Now a dimension means a combination of all. A dimension means this entire thing is a dimension. The dimension table, SID table, attribute table, text table, entire thing I call it as a dimension. Okay. So this is about the theoretically about the cube. Okay. So whenever we are designing DSO, if you recollect, can you tell me where do we place our objects while designing DSO?
Oh, we put in. You talking about key field and data field? That's what you're talking about?
Correct. Perfect. So in the key field and data field. Likewise, if I am creating a cube, let us see. Even until now we have discussed about fact table, dimension table, all these things. But when we are designing cube, we don't do anything. We'll see this. So what you are observing, you put it into key figures. All key figures you put into key figures. All characteristics you create dimensions. One by one you create. How many ever dimensions you have, you create them. Like material, customer. Clear?
Okay.
Okay. So simple thing. So now you realize, right? So we are just putting we are placing the objects. When the cube is getting activated, all the tables, the linkings will get generated. That's the all work done by the system.
Okay.
Okay. So just you have to know the understanding that how my design should be. If I place objects in this way, will my access be slow? Will my access be fast? How the links will be? So that's why if you would have an idea about the design. Like, can I put, like, do you suggest to put all the things in a single dimension? Like customer, master, everything?
No, it will, yeah, slow it down.
Correct. So that's why each area you put, each logically related area, you put it into a different dimension. So from a design point of view, you should have some understanding about how it will impact in the back end. That's the reason we have learned the schema design. Okay, so what you are observing over here, by default, system has given us 3 dimensions. We have not created data packet, time and unit. System has created it. So what we can say is, whenever we are designing InfoCube, we have 2 folders, dimensions and key figures. We place characteristics under dimensions and key figures under key figures. Okay. So InfoCube has maximum 16 dimensions. Out of these, 3 are default. Data packet, time and unit. Just now we have seen it, right? They are default. Maximum. So out of 16, 3 are default. So we can use maximum 13.
Okay.
Then in each dimension you can have 248 characteristics. Each dimension. And in total we can have 233 key figures. These values you should remember, all these things.
Okay.
Okay. Yes, we have to okay. So, and likewise there are 2 types of cubes. Just like types of DSOs, we have types of cubes, standard cube and real-time cube. What's a real-time cube? I will tell you later on. Okay. So with this I would stop for today. We'll meet again tomorrow.
Okay.
So if I get time, I create the DSO, but I didn't get time anything. I don't expect getting the time also. So can you create the DSO so that I can show the process chain? It would be a practice to you also if you have time.
Okay, I'll try.
Okay.
Okay.
Fine. Okay.
Thanks.
Bye.
Bye-bye.
Thank you.